Hello everyone, welcome to this part of Active Directory Certificate Service Stack series. In this video, we'll look into ESC10, which takes advantage of weak certificate mapping for S-channel authentication. And this privilege escalation happens because of how S-channel's logic handles certificate mapping. S-channel is a security extension that supports TLS for protocols such as LDAP and HTTP in Windows. And when you use S-channel, the default certificate mapping you set for the ADCS is ignored. For example, even if you set secure mapping to map via SID, which is security identifier, this is the most secure way, it will still be ignored then when you authenticate to S-channel. And instead is defined by the value set for certificate mapping methods in the registry for S-channel security extension. So if it's set to 0x4 or other default values on older domain controllers, it's going to allow you to do a UPN-based mapping, meaning we can spoof anyone's UPN if we have permissions to update UPN for a user. This privilege escalation is a lot harder to detect, as usually you need admin rights to verify that DC has the vulnerable registry value set to 0x4 or similar ones. We'll look into more using the wiki, so you pretty much cannot detect it using certify or other means because you do need admin rights to actually get that value. But still, it's worth giving a shot and see if it works. For example, I have a domain controller here, which is 2022, and by default actually has insecure value, which is 0x2, I believe, so it's not set. So this is by default vulnerable. So it's always worth checking if you're not against 2025 DC. I think that one for sure has it set to a secure value. You should just give it a shot. Alright, let's dive in. As always, first we'll look into the wiki, and basically says exactly what I said, explains what S-channel is, and to abuse ESC10 we can look at the certificate mapping methods, and if it's set to any of this, so if it's 0x4, 0xc, 0x1, 00x1f, this will include UPN mapping, so we can actually abuse it. But again, we cannot find it with certify, and I'll show you why. And here talks a little bit more about the exploitation. So essentially, similar to EC9, we need some kind of user we need to that has generic right or generic old DACL or update UPN permission to update the UPN of another user. And we update UPN to something like DC01 because we want to avoid UPN collision because computers usually don't have UPNs. That's kind of how it works. So yeah, we updated, then we're gonna get a certificate, we're gonna reverse the UPN, and I'm gonna use S-channel to impersonate the main controller. That's kind of the gist of it. We'll go through it and see how it works. There are also two ways to abuse ESC10 similar to EC9. You have A and B. A is basically abusing UPN, and B is to abuse DNS name, which is kind of similar. In this video, I'll just show EC10A. Alright, let's dive in. As always, I have my environment here. I got my Kali VM, I got my domain controller, and I got my ADCS certificate services server. So in here I have an EC10 template, which if you just take a look, it's not misconfigured. Like the only misconfiguration I have is allowed authenticate users to enroll to the template, because this is a requirement. You need to be able to enroll into a template that has ETU set for client authentication, and I do have it on here. But on its own, it doesn't allow send specification. If we go to, I think in Schannel, it's under, oh my god, where did it go? So the user doesn't supply subject and specifies a UPN. There are no misconfigurations, and we'll run certify and we'll see that we'll not find anything. So yeah, let's dive in. As always, first we'll just run certify find to see if we can find any vulnerabilities. I will do just standard certify find dash vulnerable to see if there are any vulnerable templates. Give it our username and password, which is ppark in our case, the main controller IP, and we're gonna just print it out as turned out because I don't want to save it to a file. And yeah, as you can see, it could not find any certificate templates, but you're gonna see that's still exploitable. So yeah, step number one, we can just refer to the wiki as we go. I already have all the commands on my other screen, but yeah, step one, we want to read our initial user CPN. Usually you would have some kind of tackle over another user. In this case, in my lab environment, I shall have my user pparker set up in a way that the user can modify his own UPN. You might see it in the real world. I don't think it's as often. Usually you would compromise like a help desk person that has account operators, and they would be able to set UPNs for any user. So here we'll do a command like this to read our first read our own UPN for user pparker, which is our user. So it's a certify account, we give it username and password, domain controller IP, user want to read the UPN from, and our action, which is read in this case. So I just want to take a note of this, better save it somewhere so we could restore it back to make sure we don't use our preparations and we can bring our back into the clean state before we start our pen test or red team engagement. So we just save it. Next one, what we need to do is set a UPN for that will match the main controller some account name. In my case, I already know what this is. In your case, you'd have to do some kind of LDAP query or run bloodhound as this user or rusthound and see what that looks like, or maybe LDAP search. But yeah, in this case, I already know it's hide ADCS, so I'll just set it to this one. So I'll just set to Peter Parker account, Peter Parker password, domain controller IP, and my UPN will be hide ADC. You do need to specify $sign because this is important. And you need to give it the domain name as well. Then give our target user, which is going to be P. Parker in our case. For you, again, as I mentioned, you'd have to find a username you can modify UPN for, might be someone else. And we hit update, so now UPN has been updated, and if we read it again for Peter Parker, we can see that it's set to domain controller's same account name. All right, our next step is just to get a certificate. Sorry, not certificate. We need to get a Kerberos ticket as this user because we need to use Kerberos for this stack to work. So as always, we can use get key from inpacket and give it our username and password. For this, make sure you have your Kerberos setup configured. I have a video that will pop up in your top right corner. It talks about WinRM from Windows, how to use WinRM from Linux to connect to Windows, and it explains how you can set up in more details. You can go check it out if you're interested. But right now we'll just get a ticket. Alright, so now we got a ticket for Peter Parker. We need to export it. Oops, specify the minus. Alright, so now we export the ticket so it could be used with Kerberos from Linux, and now what we wanna do is we wanna request a certificate. So here in my case, I already have all the variables, but if you run certify find command, you would see all of those. It would give you the ADCS endpoint, domain controller people already know, and we specify -k to make sure we use Kerberos with our ticket. And the template, as I showed you before, is ESC10 in our case. Oops, my DC just died. I realized I need to power it on. Otherwise, it might fail. So yeah, this is our template. So I'll just wait, give a second for DC to power on, and then we'll run this command to get a certificate. Shouldn't take long, so I don't want to pause the video. But yeah, if we go back to wiki in the meantime, so yeah, we just set the UPN to the target DC system account name, and you have to make sure it has suffix with the domain, which we did. So then we get a Kerberos ticket for our user and set it. Next, we want to get the certificate from the vulnerable, well, not vulnerable, but template that meets the requirements, in our case, client authentication. All right, I think our DC should be back on. Yep, it is. So let's run our command. Some didn't work. Kerberos server not found. Kerberos database. Let's try again. Tick it again. Server. Oh, my ADCS endpoint is incorrect in my command, and I think CA as well. Let me just show you how to get those values from certify command. So here you can see that CA name is this and DNS name for the ADCS server is this. So let's just set those. Make sure they're correct. Sometimes it's useful to show there so people learn from the mistakes of others. Happens a lot. Alright, now we should be good. Alright, and here we can see the expected output. So it matched the UPN instead of the SID. So we got the certificate for hide.dc. And our next step is we need to revert the UPN back to make sure it is not set anymore for anyone. I'll just go back to our previous command where we set it. And here we specify the UPN we saved, which the user had by default. Parker update. All right. So now's the most important part. Now that we got all the prerequisites and we got a certificate with the UPN for hide.dc, we can authenticate against LDAP Schannel via LDAP, and we'll get an LDAP shell as a domain controller. And remember, I didn't make any changes. This is just default domain controller 2022. There are no misconfigurations. The only misconfigurations that our template allows users to authenticate, which I don't think it's very uncommon. All right, now let's run certify auth command with LDAP shell flag. This is important. We need to specify this to force Schannel authentication. All right, let's hit enter. And it worked, and looks like we authenticate as a domain controller, which is super cool. If we do help, we can do different commands. So from here, the best way to escalate privileges is to perform a resource-based constraint delegation attack, which is RBCD. And I made a video on this, which is gonna pop up in your top right corner. And you can go there and watch the full explanation. I go into details about how RBCD works. But here in this video, I'm just going to demonstrate it real quick to see what you can do with this attack, how you can get full domain compromise. Simply from ESC10 straight to the main admin. To go like this, you first need to add a computer. The command will look like this: add computer, something like ESC10, and you give it the password super secure. I already have a computer, so I'm not going to do this, but this is what you would do first. And next command is to set RBCD. And you give it our domain controller's semi-colon name, which is hide.dc in my case. You need to make sure to specify $signs. And you need to give our computer that you created first. So this kind of sets up a resource-based constraint delegation. I already did it, so it's probably gonna fail for me. Yeah, grant is already permitted to perform delegation, so I can just clear it and set it again. Just clear command. I can just clear. Alright, and now we'll set again. So also something like this. ESC10 computer, which we just created, can now impersonate users and hide their DC via S4U to proxy, which is resource-based constraint delegation. That's a mouthful. So now we can click exit, and now we can do RBCD. So when you do RBCD, you'll get this error. I have to wrestle it for a second. So this is the command. Again, I'll pop it up in the top right corner for you to go over RBCD to learn about it in the video I created earlier, or you can just Google it or whatever you like. You don't have to necessarily watch my videos, it's just a way for me to promote myself. So if you run this command, you'll get this error, KRB up error bad match ticket and authentication.match. And it took me a second to figure out what the hell is going on, like, because this is the correct command. I checked all the parameters. Like, what's going on here? I checked the clock skew, it was all good. So the problem is, remember when we set our ticket to use Peter Parker? So for some reason, getST.py prefers Kerberos authentication to our specified credentials. So right now we're just using our Kerberos ticket, which does not have RBCD set. So therefore it's failing. So what we need to do is do unset. It's gonna unset the variable, and now we won't have any tickets in our environmental variables for Kerberos to use. And if I run this again, that's not what I was expecting. Oh, I did the command wrong. You just do unset KB569. Oops. Here. Now it's gonna work. So now we got an administrator ticket on the domain controller that we can just use with some like psexec. Oh, we have to export it first. And now we can use psexec -k-nopy, nopy. I'm typing. -k-nopas and our domain controller fkdn. Make sure you have it in your host file, but again, show it in my previous videos if you wanna go watch those. Demonstrate all this. And we get a shell as a system on a domain controller. Oops, hide the DC. And we compromise the full domain from a regular user, which is kind of cool. Alright, now let's go over remediation for this. And again, always refer to Certify Wiki. This is the best resource for ADCS attacks. So the recommendation is we configure Schannel certificate mapping to 0x18 value, which is the strongest one. And as I mentioned, because of this KB, I think if you have it installed, it does it by default, unless you explicitly set it to something like unsecure. So if it's not set, as in my case here on DC 2022, I would have to log in again. Let me open this. This is not where it should be. I just copy and paste. Can I copy and paste? I can't. This is not what I want. 1 second, because my D series started. Messed up a few things. So here, if I query this certificate mapping methods, just expand this. It can't find it because it's set to default. And therefore, if you install the keyb now, knowledge base article, or the update, it would set to a secure value, but I guess not. Doesn't come with DC 2022 by default. That's my guess. But yeah, if we set this attack will no longer work, and we should have strong Kerberos certificate buy-in first. This also helps. But this is the main one. You need to make sure this is set to 0x18, which you can set it like this. It might cause some compatibility problems. I'm not too sure about that. I haven't looked at it and I don't administer ADCS. So it's best to check with Microsoft and Google a little bit to make sure it doesn't cause any problems for your environment. But you also have to make sure you set on all domain controllers, not just on one. You have multiple ones. And usually in enterprise environments, you have multiple ones. So now that we set it and require it, it's set to 24, which should be secure. Let's try to do the attack again to make sure. And let me just remove everything right there. And administrator. Might require a reboot, so let's just give it a shot and see if it doesn't work. It might require a reboot because I tested before and it did stop the attack 100%. So let's see. Looks like it might require a reboot. Schannel, I think last time it was 03, not 06. But let's see. Let's fix it or it requires a reboot. Yeah, looks like it does need a reboot potentially, or you need to restart ADCS maybe. Yeah, that didn't work unfortunately. But yeah, this 100% fixes the problem if you do a restart. And also, you need to make sure this value is set. Alright, thank you for watching. I hope this was helpful. I'll also link another resource and talks about mitigations, so you could read up on this more and fix your environment and stay safe. Thank you for watching. I'll see you in the next one.